Hello? Hello? Hello?
Yes, ma'am.
Students join.
Yes, ma'am.
Shall we start the class?
Yes, ma'am.
Yes, ma'am.
Yes. Good morning, everybody. So today we will have class on factors affecting cultivation of food drugs. So already we have seen about the cultivation of the factors, propagation, and apart from that, then processing also we have seen. And in today's class, we can see factors affecting the cultivation of crude drugs. I request all of them to remain silent. So, cultivation of plants offers the wide range of advantages over the plants obtained from the wild sources. And there are few factors which really have the effect on the growth and development of the plant. So, under the growth development, the nature and quantity of the secondary metabolites produced also will have the effect of these factors. The various factors which affects cultivation are altitude, temperature, rainfall, length of the day, daylight, soil and soil fertility, and fertilizers, and pest control. Apart from this, there is also another factor that is called as the plant growth regulators. Plant growth regulators also will have some effect on the cultivation of your plants. And the effects of these factors were studied by growing the particular plants in different environmental conditions, and the various changes have been observed. So in this context, if you see an example, that is when a plant is subjected to grow in an environment, may develop as a small plant, sometimes with a high proportion of metabolite than the other plants, which is attained the required growth in the wild plants. And the nutrients what you are providing will have the ability to increase the production of secondary metabolites. At the same time, they may also reduce the production of secondary metabolites as well. And the very first factor which influence the cultivation of crude drugs is the altitude. It is a very important factor in the cultivation of crude drugs. For example, if you see tea, cinchona, or eucalyptus, they usually grow at a little bit high altitude, that is from the sea level, 1000 to 2000 meters. And when you just see about the well-known plants for you, like your cinnamon and cardamom, they also grow at an altitude of around 500 to 1000 meters. Whereas if you take your senna leaves, they are cultivated on the sea level, that is on the plains. And here I can show you some of the examples where they can produce or where they can grow successfully. Here tea around 1000 to 1500, cinchona around 1000 to 2000, camphor 1500 to 2500, cinnamon at an altitude of 250 to 1000 meters from sea level, and coffee from 1000 to 2000 meters from the sea level, clove up to 900 meters from the sea level, saffron up to 1250, and the cardamom around 600 to 1000 meters from the sea level. And next comes the temperature. It is also an important factor which affects the cultivation of your crude drugs. And also it is crucial factor which involves in the growth, metabolism, and yield of the secondary metabolites. Each and every plant, it will get adapted to its own natural environment. And in that considerable range of temperature, they grow very well. And some of the plants or most of the plants will grow better in the temperate regions, whereas that is especially in the summer. Usually we say tropical and subtropical regions, right? When we study about the individual collection and cultivation and collection, I might have told you the plants will grow under the tropical and subtropical regions. So that means it grows in the temperate regions where it has the little bit more temperature. And they lack in resistance to withstand the frost in the winter. That means the plants which grows in the tropical and subtropical regions, they cannot withstand the fog or frost in the winter season. So here I have listed out some of the plants which grows in their optimum temperature, that is in the Fahrenheit, not in the centigrade. Cinchona around 60 to 75 degrees Fahrenheit, coffee around 55 to 70 degrees Fahrenheit, tea around 70 to 90 degrees Fahrenheit, and cardamom around 50 to 100 degrees of Fahrenheit. And next factor is the rainfall. So any plant, if you want to grow or cultivate, for its proper development, proper rainfall is required. And you know, there are some xerophytic plants, that is especially aloes you might have seen, it may not require any irrigation or the rainfall. Apart from these xerophytic plants, the other plants have the effects of rainfall over their cultivation. Usually these plants will require the annual rainfall of sufficient level with water holding properties in the soil. What do you mean by that water holding properties? That is nothing but the soil will have the pores, air spaces, along with the presence of your minerals and other things. So those pores will allow the water to hold in between. That is called as the water holding property of the soil. And you can get variable results under the different conditions of rainfall. Sometimes the excessive rainfall may cause reduction in the secondary metabolites. How it will cause reduction in secondary metabolites? Because of the excessive amount of rainfall falling over the plants, leaching of the water soluble substances will takes place. That means all the water soluble components will get solubilized in the water and go away from the various parts of the plant wherever it is stored. And next factor is the day length and daylight. It has been proved that even the day length has an effect over the metabolites production. The plants which are kept in the long day conditions, that is especially in the summer again, may contain more or sometimes less amount of the constituents when they compared with the plants which are kept in the short day, that is nothing but during the winter. Here to support this, an example, that is in the peppermint plant, in the long day conditions, almost all the different active ingredients of the volatile oil component are produced, that is like menthone, menthol, and traces of menthofuran, all are produced in the long day light. Whereas in a short day condition, only menthofuran is produced, not the important constituents like your menthol and menthol. And also the daylight was found to increase more amount of production of alkaloids in belladonna, stramonium, cinchona, etc. And that's how the examples which have the effect due to its day length and daylight as well. And next point or the next factor is the soil. Soil is a very important criteria for the plant to grow. That is, every plant will have its own soil and nutritive requirements. There are three basic characteristics of the soil which supports the growth of the plant. They are the physical properties, the chemical properties, and microbiological properties of the soils. So what does this soil do? It provides the mechanical support to the plant. How it is providing the mechanical support? It helps the plant with the help of the roots to get anchored or to stand firmly in the ground or in the soil. And they also get water and essential food materials which is required for its normal growth and functions for its development. As I already told you, the soil, it consists of air, water, mineral matters, and organic substances. Usually, this water and air are present in the air pores which are present in the soil. You might have studied well about the soil in your lower classes. That is, in geography, you might have studied about the various plates of the earth and different the layers and the soil. What does it constitute of? When you just see the soil, it consists of the mineral matters in the different particle size. So because of these differences in the particle size, the soil can be classified into different categories, maybe like clay, sand, gravel, and so on. And the particle size variation also influences the water holding capacity of the soil. The type and the amount of minerals present in the soil plays a vital role in the growth and the production of the secondary metabolites in the plant. And also, you know, one of the important mineral, that is the element calcium, which favors the growth of some plants, and with some plants it will not have any effects. And later we will see the amount of calcium present in the soil is called or categorized as calcareous soil. And the plants are able to determine their own soil pH range, and they get accustomed with that kind of soil. Especially when you say cinchona, usually it grows in the acidic pH of around 4.5. The microbes which are present in the soil are also to be taken into consideration when uh, because they grow well in certain conditions of pH. You know, when you're cultivating your microbes in the in vitro level, you need to maintain the pH, right? So that is why the microbes also are considered in this criteria. And also your soil should contain nitrogen wherever you are cultivating the plants which produces alkaloids. And here you can see the types of soil based on the particle size. I have categorized here the one side the particle size in diameter and the type of soil. The soil particles, if it has the diameter less than 0.002 millimeter, it is called as fine clay. If the particle size is between 0.002 to 0.02 millimeters, it is called as coarse clay or slit soil. If the particle size is 0.2 millimeters, it is called as the fine sand. Or if it is between 0.2 to 2 millimeters in diameter, it is called as the coarse sand. Okay, so that's how the soil is categorized into different types based on the particle size. Till now, you might be wondering when I used to tell the different types of soil during cultivation of plants. I think now you might have got an idea that how the soil is classified based on the particle size in diameters. And next, the soil also can be classified based on the percentage of clay present in it. So here I have again categorized the type of the soil along with the percentage of clay it contains. The type of soil is clay. If it contains more than 50% of clay soil, that clay means what? It should have the particle size lesser than 0.002 millimeters. That is called as your clay. And next one is the loamy soil, which contains around 30 to 50% of clay. And the other type of soil is called as slit loam, where the percentage of clay is 20 to 30%. And the next category is sandy loam, where the percentage of clay is around 10 to 20. And the soil is called as sandy soil if it contains more than 70% of sand. That means the clay percent will be less than the 30%, maybe 20, 10, or still more less than that. And there is another category of soil which is called as your calcareous soil. Already I mentioned that the amount of uh, lime, that is nothing but your calcium hydroxide present should be, calcium carbonate should be present about the 20%, more than 20%. So this is the classification of soil based on the amount of clay present in it. And next one is the soil fertility. What do you mean by soil fertility? It is the capacity of the soil to provide the nutrients in adequate amount and in the balanced proportion to the plants. Yes, when a plant is planted in a ground, the ground or the soil should be in a position to provide all the necessary nutrients to the plants in the correct proportions. That is called as your soil fertility. If the cropping is done without fortification of the soil fertility is lost. What do you mean by this? That means you are cropping a particular plant, and when that harvesting is over, without supplying any manure or fertilizer to that soil, if you are planting the next crop in the same field, that means the soil in that particular field is not having its fertility. That means all the nutrients will be deprived from the soil, because whatever the nutrients were present in the soil, that was used by the plants which you have cropped earlier. And for the plants what you are going to crop now, the soil will not be in a position to give out the nutrients the plants are requiring, right? So that is why in between the two cropping, you have to fortify the soil with the necessary nutrients. How will you fortify? That means by providing the manure into the soil, so that the soil, whatever the nutrients it has lost from it, it will gain all its lost nutrients from the manure and other kinds of fertilizers. Okay, and the soil fertility is sometimes it is decreased through leaching or erosion. Leaching is what? When more amount of water is falling on the plants, that is, or the soil, the nutrients will be leached out or removed due to the much water flow, or sometimes due to erosion, the loss of nutrients will be happening. And the soil fertility can be maintained by the addition of animal manures, or by the addition of nitrogen fixing bacteria, or by the application of chemical fertilizers. And next we will see about the fertilizers and the manures. Usually the plant needs food for their growth and the development. Carbon dioxide, sun rays, water, and mineral matter from the soil. Usually the air can be obtained from the atmosphere, and the light can be obtained from the sun rays, and water can be absorbed from the soil, and mineral matter also can be taken from the soil. The chemical fertilizers, that is, usually plants require around 16 elemental nutrients for synthesizing various compounds. The primary nutrients are considered, that means which are to be required in large quantity. They are nitrogen, phosphorus, and potassium. And secondary nutrients are called as the substances required in small quantities, that is magnesium, calcium, sulfur. And the next class is called as micronutrients or trace elements. It includes copper, manganese, iron, boron, molybdenum, zinc, etc. Okay, these are the different categories of nutrients based on their requirements. They are called as primary, secondary, or trace elements. As I already told you, carbon, hydrogen, oxygen, and chlorine, they can be taken from the water or otherwise from the air. And each and every element, whatever we have seen now, they have its own functions in the growth and development of the plants, and also in the production of the secondary metabolites. If deficiency of any of these elements will characterize by some symptoms. And next, when you see the manures are nothing but they mainly consist of the organic substances. Here I had given you some of the examples, that is farmyard manures, castor seed cakes, poultry manures, that is the waste from the poultries, and neem or currant seed cakes, vermi compost, etc. are the examples of your manures. And when you just take the oil cake or the compost, it consists of around 3 to 6 percentage of nitrogen, 2 percentage of your phosphates, and 1 to 1.5 percentage of your potash. And also you can provide the organic fertilizers like the bone meal, fish meal, biogas slurry, blood meal, or breast milk. In the olden days, you might have seen, that is in the villages near to the house, what they do, they used to collect all kinds of waste materials from the houses, apart from the waste material from the cow shed or cattle shed or whatever it is. And that will be collected and collected and collected. And after 3 to 4 months, they take all these things and they put it in the land before they process the land for the cultivation of paddy or ragi or whatever they do. I think most of you, you might have heard or you might have seen, or if you have not heard about it, you ask this about these things to your grandparents. Okay, so they might be telling their experiences, right? So that is called as your organic manure. And this manure, when you supply to the field during the processing, that will fortify the soil with the organic matter. And again, the types or the soil is classified based on the percentage of organic matter present in the soil. So based on this, the soil can be categorized into 3 types. One is the rich soil, intermediate soil, and poor soil. That is again based on the percentage of organic matter present. If the organic matter is in between 1.5 to 2.5 percentage, the soil is considered to be rich soil. And if the percentage of organic matter is in between 0.5 to 1.5%, it is called as the intermediate soil. And if the soil present, or if the soil contains the organic matter lesser than 0.5%, it is called as the poor soil. So we have seen the classification of soil based on the particle size, based on the percentage of clay present, and this is then another classification based on the percentage of organic matter. And then the last point in the soil is the biofertilizers. That is nothing but it consists of the microorganisms or the lower organisms which fix the atmospheric nitrogen in the soil and the plant. And usually these microorganisms are symbiotic in nature. That means they help the plants to grow and they take up their nutrients from the soil as well as from the plants. The examples of the microbes which are used or which are friendly in fortifying the soil are the rhizobium, azobacter species, azospirillum, Begericia, and the little bit higher organisms like your blue-green algae, azella. All these are considered to be the examples of biofertilizers. Okay. So these are all the various factors and things regarding the soil and soil fertility. So till now we have seen the various factors which affects the uh, cultivation of crude drugs are the altitude, temperature, rainfall and humidity, and the effect of day length and day light, and then you have our soil and soil fertility. So with this we'll stop this class, and in the next class we'll see about the pest and pest control. Thank you.
Thank you, ma'am. Ma'am, there
Thank you,
is no
ma'am.
network
Yes.
at all.
Thank you, ma'am.
Yes. Any doubt?
There is call out. Like,
Any doubt?
No, ma'am.
Shall we stop the class?
yes, ma'am.
Any points?
Ma'am.
I'll
Yes,
share
ma'am.
the recorded video through the link. Okay.
Yes, ma'am.
Thank you.
Thank you.